So we just kind of walked through sketching out lofted surface, extruded surface, things of that nature. And we're going to walk through the SolidWorks commands of those. And then we're going to circle back to sketching it out, because that's going to be your assignment for this week, for next class. And it's going to be a blend of, sketching to get used to form development, and sketching what you want it to look like, and then creating it in CAD. So first thing we talked about is we're going to do a swept surface, which involves at least one sketch. So we're going to just come in here and we're going to do a sketch. And I'm not going to be fancy with the sketch and things like that. So just to reinforce, we've got a singular curve, and we're going to do an extrude or surface extrude. And with that said, what that means is we only have control at one point, and that defines everything else. This curve that we just created, this sketch, is going to go in a straight line. And it's going to, the end is going to be the exact same look as the start, and the edges are going to be straight lines. We have no other control over it than that. The next one is to do a swept surface. A swept surface needs a sketch profile, and a sketch profile is a open profile. But then it also needs a path. So what we can then do is come in and we'll draw our second line, or our second sketch. This will end up being our path. And we're going to notice something here when we do this. These are not touching. But what we have is we have the requirements now for a swept surface. We have a sketch profile, which we're going to use this, and then we have a path. Now what you can see is they're not touching, and it's determining what one is following along the line. So here we said this is the profile, and we want the profile to remain there, and we want it to follow this path. We only have control at this end again, and the path that it follows. If I was to come back, I could select this as my path, or my profile, and this is my path. And now you see what happens is that it follows, the surface starts up at where we select it first. So it's going to start where the profile is. Now, let me just go back and show you one thing again here. So if I use that as my profile, this is where it's going to start. We're going to go and do our path, and that's where it's going to be. And you can see it does the full width, because it knows that we want to have a swept surface from this point to this point and follow all the way along there. If you notice though, the end result of how it looks at the end is not necessarily, it is what it is. That is the path that it takes. It's taking a curve and it's just dragging it along that edge. And how it ends is that natural shape of it. So it's not giving us necessarily something pretty, but it maybe that's all we want. Now, if we switch these and we say that we want this to be our profile and we want this to be our path, you see that it only does it in one direction, because it's not smart enough to know. It knows, oh, here's a path. My curve starts here. If I look at the top, my curve starts here on this path, and it goes to the right. It doesn't know whether it should go to the left or the right. So what they've done is they've given you the option. Do you want it to go to the left? Or sorry, to the right? Do you want it to go to the left? Or do you want it to start in the middle and go to both ends? So you have those options. And it depends on what area you want to control. Maybe I don't care where this curve is, but I want to make sure from a side view that this is the top of the surface. So that's going to be what I would call my control spline. That's where I want the top of the surface to be. Does that make sense between those little features? Is that a yes? Awesome. Let me.
Yeah.
There you go. Sorry, I don't have the chat on, so I wasn't seeing. Okay. Now, oops. Obviously, it's parametric. So we can come back to our sketch and we can adjust our curve and get completely different shapes. Let me delete that out. Now, right now I'm just doing very loosey-goosey surfaces. I'm not doing anything with constraints. I want to try to keep this simple and free form for now. We're going to eventually get into really constraining things down the road. So the next is, like we talked about, doing the loft. Now, if you want to think about it like this too, is the more complex the shape, the more control I may need. So the more control, the more math data behind it, which means that it is going to be a heavier model. So let us hide those. And I'm going to come in and we're going to do another sketch. Now, we've already spoken that a lot of SolidWorks is on sketch planes, and we'll also get into using 3D splines when appropriate. But to create surfaces, there's going to be a lot of planes to build. So I want to create a loft, so that means I need to have at least a start and an end point. So I'm going to come in and I'm going to go Insert, Reference Geometry, Plane, and we're just going to create a plane. Sorry, I'll walk through every step that I do. We're going to go Insert, Reference Geometry, Plane. I'm using the front plane. For the sake of this, I'm just going to go in the opposite direction. We're going to make it 60. And then I'm actually, in Foresight, I'm going to actually do another one too. So we're going to do 2. Now, really neat trick. I'm going to, here's my sketch, here's my curve. I need to loft it down to this endpoint. I want to make sure that my starting points are identical, let's say. I'm going to go Control C. As I select that line, I'm going to select this plane. I'm going to go Control V. It created that sketch, that duplicate sketch, onto this plane in the exact same spot.
Can you do that one more time, please?
Yep. Okay, so we've created the sketch. So I'm going to come in, I'm going to select the sketch. I can either select the line or select the sketch. And I'm going to go Control C. So I've copied that sketch. It's like doing a photocopy. I'm going to say, I want to copy that sketch onto that plane. So now I have 2 sketches. Now they are not related. So if I change this, the other one does not update. So they are independent of each other. Does that make sense?
Yes, thank you.
Okay. Where this can be useful sometimes is starting with a base form and then going to modify. Because what I can then do is I can come in and say, okay, well, I'm going to use my loft command, and I'm going to loft from this profile to this profile. Which again, as we understood, as we sketched out, I have no control over this edge, over this edge. It's a direct connect, dot to dot. I only control what happens in the start and in the end. If I come and I go to this sketch and I edit this, I then get my new shape.
Emma, we can hear you.
I have.
Oh my god, I'm so embarrassed of it.
I do not control what happens in the middle. The software does. It's going to take this shape and transition from A to B, and it's going to be a 50% rate of exchange. So what that means is at the middle mark here, this curve is going to be 50% of the end and 50% of the start. Now, I can come in and say, oh, well, I want a slightly different shape. So I'm going to come back here. I'm going to copy that sketch in there again because I want to control what that does in the middle. So I can come back and either I could create a new surface, you know, I could delete this surface, or I could say, you know what, I'm going to edit this surface, and what I'm going to do is I'm going to, oh, nope, I can't. Okay, so here's a good thing. Here's a good thing for me to show you. I came in, I created this, let's do this. I created this surface. I then said, I don't like this surface because I don't have the control in the middle here that I want. I want to add control. So I created a sketch, so I now have 3 things to loft to. Well, I want to edit this surface. Well, in order to edit this surface, it goes back in history. I created that sketch prior or after creating this surface. So when I go to edit it, I can't add that sketch in because it wasn't created at the same, it wasn't created before I created the surface. But what I can do is I can say, oh, I guess I do want it. I'm going to move that up there. So did you see what I did there where I moved the sketch and created it prior to? That allows me now to go edit, and it's still there. So I can grab this, and this is a very important thing here. I grabbed that sketch, and see what it did? It's not showing me the boundaries, and it's giving me these dots. It needs to know that it's going from this point to this point. Well, because I selected on this side of this curve, it's now, it's assuming that I want to loft this curve from this point to this point to this point, which mathematically it can't figure out. So I have to either drag that green dot over to here, or when I select it, I need to make sure I select it on the same edge. So now I've got that control. So now what's happening is, because this curve is the same as this one, this shape stays the same as from here to here. And now I've moved the transition point of blending from this shape, or this curve to this curve profile, to the middle of there. So now I still don't have control to the outside edges because it's still going in that straight line. Questions?
So is it kind of the same concept as the extrude law?
Pretty much, yes. It's the same as the extrude. So you can see the first one I could extrude it in a straight line. Now, by doing that swept, I could add a little bit of a curve to it. Each time, each one of these surface commands allows me to get a little bit more control, a little bit more complexity. Excuse me. With it. So now I'm saying extrude, but I'm giving it various commands to extrude through. Okay, so as we continue, we are still missing any kind of control along this outside edge. So let's come back, and you know what, we're going to delete this. And what I'm going to do is I'm going to create, now I know because I copied all these sketches that all these points are in the exact same position. So I'm going to come in and I'm going to insert, because I want to create a sketch. Oops, let me do this. I now want to control that edge. So what I can do is I need to create a curve. In order to create a curve, I need to create a plane. So I'm going to come back. I'll delete this surface. You know what? Let me just do this. No, that's not what I want to do. Insert. Come on, Chevy. So I'm just moving, copying. So I'm just going to move this. Oh, that sucks. Okay, never mind. Because I want to delete it, so it's going to get rid of it. But anyways, so I know that all these edges are on the same point. So I'm going to come in, I'm going to go Insert, Reference Geometry Plane. I'm going to select that, and I want it to snap to that point. Because for this, if I'm going to do a loft, if I'm going to add that curve, these points need to be closed. They need to be connected. So let me just show you first. If I come in and say I'm going to draw along here, and I want that path, I want it to follow that. So I'm going to come in, and we're going to go and we're going to do our lofted surface. And I'm going to say I want to go from here to here, clicking the same ends. If not, I'm going to get that easily fixed. I can either grab that dot and drag it to get it to the right one, or I can come up here, I can, come on. Oh, it's not going to let me do that. Wrong software. But now I'm going to say guide curve is here. Well, that is very interesting. That did something that I was not expecting whatsoever. It, in theory, was not supposed to follow that because it wasn't touching. let me just do something here quickly. So maybe we're learning something new with it got smarter a little bit. Because normally SolidWorks is an extremely rigid software package, not as rigid as Creo. And if you talk to any of the students who have done a internship at Delta, they will talk to the industrial designers who use Creo. They will tell you it's not a very industrial design friendly software package because it's very, very strict. So what I wanted to do is, okay. So you can see that there's a little bit of a problem in the sense that it doesn't match up with that perfectly. So I just want to see if I correct it here, if I can edit that. Oh, interesting. Okay. Okay, so still good example. So we'll do a big exaggeration. I've got my curve here going to here and I want it to follow this path. Notice this path does not properly connect. What happens is, again, your surface is only as good as your data. So the software knows at this point here, I want it to match this curve. At this endpoint, I want it to match this curve. And I want to follow this path. Well, it knows here that this curve connects to here. So that's going to be good enough. It knows what to do. But the moment it starts transitioning, it's fighting. Because it doesn't know whether it should follow it. You've told it to follow this, but then at the same time you've told it to end here. So it's trying to figure out what to do. If I come in and I adjust this, you can see that the surface changes. So if I wanted to match that, then I need to have it connected to that dot. Come on. Did we all see that or notice that? Is that a yes? That's a yes.
It's a yes.
Okay. So, and again, if I want to make it more complex, I can then add to this section here and control all four corners. Now, this is where it gets to be a bit of a pain. The order of the curves that you created in, this is going to be why we want to understand how we're going to build things. And we're going to understand that down the line. I'm going to come in and I'm going to create another surface over on this side. Now, I can't just copy this from there to there, or can I? I don't know if they're mirrored. Nope, I can't. So I'm going to come in. Now, in this surface, we have all four boundaries defined on the exterior boundaries of this surface. We don't control the middle. Well, let's say, hey, we want to use this to control the middle. So I need to now connect this to this curve. I'm going to come in and edit it. Does anybody want to predict what's going to happen? I can't connect it to those other curves because it was created prior. So if I want to get these to connect, they're not going to. I have to come back in. I can take this sketch, and we can see it was all the way up here, and I can move it down to here so that it comes after everything. Now, I can come in and edit it. Everything is there. And this is where relations become very important. Because if I try to loft this boundary, or loft this surface, and we're going to loft from here to here to here, and we want to use this guide curve, and then we want to use this guide curve. You can see guide curve number 1 is invalid. It does not intersect with section number 2. Always read up here. That's going to give you your errors. This is what I would have expected to show up when this guide curve didn't connect with this path, this profile curve. I was shocked, although it opens up a whole new level of freedom. What we need to do is come in and add relations. So we've talked about, we want this point, and we've talked about before, concentric and tangent and all that. We're going to have a few new relationships that we're going to talk to. And the main one, we've talked about midpoint, which is snapping that edge to the midpoint of a segment. We've talked about coincident, meaning that it just touches that line. The new one is going to be pierce. And what that means is that between two different spaces, plane 2 and plane 4, we want to make sure that this line pierces this line so that there's always a connection. So we'll hit pierce, and then we'll do the same on the other end. Now we have a network of curves, and this is what this is referred to. You'll hear people talking about network of curves, edge-to-edge building, surface modeling using a network of curves. That's what we're doing right now. We're using a network of curves to create a surface, along with guide curve in the center. So we can then come in. We'll go from here to here to here. And you can see that is at the, oops, I'm using the loft command. I was going to say that at the heart of it is a loft. Well, yeah. So at the heart of it, it's a loft. It's doing that path. Then we want to do guide curves. And now we have our surface. Let me turn off our planes. It's not necessarily the prettiest surface, but it depends on what you're trying to do. Okay. Questions? Okay, so I'm going to go into a boundary surface now. So what I want to do is I want to delete this. We'll turn back on all our curves. Now, you're going to notice that I can create a boundary surface, and I'm going to go direction 1 and direction 2. Direction 1, direction 2. So I'm going to come in, and I'm going to go from there to there. I'm going to go from there to there. So, looks almost identical. I'm going to come back in. I'm going to add that direction in there. We basically have the exact same surface that we created using the loft surface. We took the exact same approach. The difference is, if you notice, we have these little control windows that pop up on each one of our curves. If we click on that, right now, our option is direction vector and normal to profile. Those are the exact same options that we have when utilizing our loft surface. So let me just come back because that was something I forgot to show. I'm going to come back and I'm going to do a loft surface. What we've got is a start constraint of a direction vector and normal to profile. Direction vector means that we can control the angle that it leaves at. So we could have it start at a 45-degree angle, or we could have it start at a 2-degree angle. That helps with draft and various things of that nature. Hold on one second. Why did you... Oh no, there. It's not letting me rotate. Oh, because I got to finish my command first. Or normal to profile. Normal to profile is, and I'll go into this more detail later. Normal to profile is, let me go to the top view here. This would be the profile here. Normal would be straight off. And I want to find a tutorial because I don't do a very good job of explaining direction vector and normal to profile. So I want to find something that explains that better. But for all intents and purposes, you only have those two options. When we come back to the boundary, we'll go from there to there, there, to there. We have the exact same options there, and that is it. Partly because there's nothing for it to attach to. If I then come in and say, okay, well, these are our boundaries, edges, they like to refer to as boundaries. I'm going to grab this surface. I'm just going to go insert, there we go. Okay, so now we have two surfaces. What I want to do is if I go loft, I can loft from this profile. And we'll get into this later. When you're building from one surface to the next surface, you don't want to use the curves. Anytime that you can use a surface edge, it is considerably better because it gives you more control, because there's more math geometry happening behind the surface, and we'll go into that too, versus using the curves. So I'm going to come in here and let me just hide that sketch there so I'm not accidentally grabbing that. Oops. There. So I'm going to come in and I'm going to loft, and I can loft from this edge to this edge. Now, things become different because I'm not using a curve. Again, you can see it's taking that edge. I don't have any control along the side. I don't have any control. It's going from this shape to this shape. This like we talked about before, is known as positional. There's not tangent, it's not anything. What I can do though, is I can come and I can go to this edge and I can say, you know what? I want it to be tangent to that face. Down off of here. Let me do this one up here. It's easier to see. So we know that tangent is like a radius. It's making a smooth edge. We're going to come in and I'm going to say I want it to be tangent. And I keep grabbing the wrong one. End constraint. Tangent. There we go. So you can see now it's modifying that surface so that it follows this curve first and is making a smooth transition. But I only have control at this edge. I don't have control on the outside. It's going in a natural path. So it's going to stay tangent off of here and come down into that area there. If I was to come in and knit these surfaces together, so we'll knit that, that, and that. Again, they're considered 3 separate surfaces until I knit them, at which point then they're viewed as one surface. And you can see at that edge, I have my phantom lines, which means that they're tangent. I can evaluate them, and just to make sure that there's no angles. Oh, look at that. There is an angle. 0.017 degree. That's not something I might like. Or I could trim away the fat. Now, I can come in and play with this surface and do what's called weights. So this little arrow controls, I'm going to blow it out, how far it follows that tangent line before it starts diving in. So you can see that I can do some not necessarily good stuff, but interesting stuff to get a form very quickly without having to build curves. Not everything has to be about building curves. Let me just come back. I want to edit that some more. So here I adjusted the weight or the length to 10. I can do a 5. I can do a 3. I can also control this end here, which is the start constraint. And the reason it's the start is because I said I want to loft from here to here. Now, I could come in and draw this as a sketch and loft it between the sketch. That would give me a little bit more control over things. I can also come in and use curvature to face, and we haven't really gotten in much into curvature because I still want to just play with the different tools within the surfacing before we dive too deep into that. Now, I can also control what's going on the outside by adding additional guide curves versus doing curvatures to face and doing those constraints. So I can come in, let us go back. Hold on one second, this is there. Now I can also come in and use the boundary tools and do the same thing. And I've got the exact same command controls over here. Tangent to face, curvature to face. Exact same controls. And I can adjust there. Downstream, when we get deeper into the boundary surface, what happens is we end up being able to get more control on all the sides of the surfaces. So for example, we could come in, and I'll just use a great example of a boundary surface here quickly. If I come in and I'm going to do a sketch, and this is called patch modeling, just as I go and I talk. I'm going to cut out a patch, and it's going to be a really simple little patch. So I'm going to cut out a little bit of a surface here. Come on. Where's my delete face? There it is. I'm staring right at it. I'm going to insert a reference plane because I want to build some curves here. Okay. So I'm just doing a few things to set some things up. You can see here I've got my surface. I'm going to insert reference geometry. I'm using my plane here. Oops, come on. So I've got some connection points, but on here I'm going to draw a sketch. And I'm going to snap it . So exact same thing. Instead of doing a lofted surface, I want even more control. So I had the original control, but now I need better control right here in this very localized area. So I'm doing patch surface modeling. I'm cutting out a patch and then I'm filling it in with the surface that I want. So I'm going to come in here, and now I'm going to use my boundary surface because I've got a defined boundary. Ooh, let's get rid of that sketch. I'm going to go here to here to here, and you can see it's not connected to the surface. I don't have any control along the edges. So I want to get control over those edges. So now I'm going to go into the directions. Now, just like we did before, we saw that these edges were broken up into two because of that split line. So no different than what we were doing with the solid modeling. I want to right click and go Selection Manager. And I'm going to select that and say that's one edge. Now I'm going to go and do the same on the other side. And go with that. I'm going to look at it, and there's my surface now. So again, I've built it. Does it look good? I've got all blue lines. Let's stitch it up. So again, this is getting into, and you'll see I do it without even thinking. This is the build. Well, actually, it's define what you're building, build it, evaluate it, and refine it. The only difference is I'm going to come in, I'm going to stitch this together. Knit, stitch. And you'll see that on this edge, I've got my dotted lines. But I don't have anything on this edge or this edge. Does anyone want to tell me why they think that might have happened? Zach.
I'm sorry, could you repeat the question?
So I've got tangent C along this edge and along this edge, the dotted lines. But I don't have it on this end and this end. Why is that?
Is there not a control curve going there?
Oh, go ahead, Fabian.
Because you didn't select them?
Well, okay, so it's a little bit of both. So I didn't tell it what to be there. With this, if I come back to my sketch that I created, with this sketch, I said, hey, I want this curve to be tangent to this edge. Same as down here. So as it goes, it knows along this edge to stay tangent. But I just let it decide what it wants to do from here to here to here. I didn't say make it tangent or anything. So what I can do is I can come back and I have, so each one of these surfaces, they're a little bit more complex, which means it gives you a little bit more control. I can come in and say, here, let me just do one thing so you guys can see this a little bit easier. There you go. I can say, right now, I'm saying, I don't care what you do there. Do whatever the hell you want. Software's like, no, I'm not doing nothing. Whatever it is, it is. You want me to go in a straight line, I'll go in a straight line. I can come back and say, make that boundary tangent. See this line? See, did anybody see how that modified? So right now that curve dives in like this. Let's turn on our curvature combs as well. And let's turn it on in that direction only. Okay. So see how it just kind of dives in there? What we're going to say is we want it to be tangent, so we need to smooth that out. So now you can see how it runs a little bit smoother. But it dives in here. So that's going to give us the hard edge. If we wanted to make this smooth, now we're going to get that smooth face. Do you guys want me to bring this into KeyShot so you can see that better?
Yeah, I think that would help.
Okay. So let's go back to okay, so we're going to go into KeyShot here. Oh, KeyShot's opening in the other window. Okay. Where's our favorite? Okay. So we can see an edge there. That's not highlights, or sorry, that's not shadows, that's not light reflections. That's an edge in the surface that's showing up. There's no transition there. But we don't have that issue along the sides. It looks like one piece, smooth and seamless. Let me try something here. Stop, let go. There, that'll do better. So you can see along here, we're getting that form. But in here, it's nice and smooth, but then we get this divot. And if that's what you want, that's what you want. That's the hard edge. But if we come back into SolidWorks and we say, no, we want this to be nice and smooth, and we want it to be in the least tangent, and we have a lot of control that we can do with the tangencies along with this as well. Let's update. You can now see that that is gone, or it should be. You can see the radius that's in there, but you don't see that edge. Does that make sense?
Yes.
Okay. I need you guys to be much more talkative, please.
I have a question.
Yes.
So would it be the same if we had like different materials in it? So if it wasn't, so let's say I didn't want like that surface, I had like glass in it. How would the glass be like how would it affect like that? And like let's say that was a window in a car. Do you get what I'm saying?
Okay. Are you saying how would that divot affect it?
Yeah. How would the
Okay, so let's do that then. Let's come in here. We're gonna go materials, glass, and the reality is the higher the reflectivity, no, that's not. I don't want wavy. Come on, just give me a standard glass. So in glass, nice and smooth here, right? If we come back to SolidWorks and we edit that, and this is going to be great because this is going to give me, I'm going to take us in a little bit of a side direction here for as we do design here and talk about some stuff about manufacturing and materials and processes. Are you guys okay with that?
Yes, sir.
Damn, that's enthusiastic. Okay, so glass window. You actually see it even more pronounced. So when we're looking at things, automotive design, look at it this way. The more reflective, the more polished, the more shiny a surface is, the more it will show all of your flaws. When I do Class A surface modeling, what Class A means is deviation amongst things. Imagine that angle that I showed you, where it had, if it was a 0.00001, unacceptable. Now, if I'm doing something that is, you know, rotational molded and a heavy texture, 0.1 degree, you're never going to see. You need to understand what your end model is going to be to understand what the end flaws are going to be, or how they're going to show up. So here, in the shiny surface, that shows off quite a bit. Now, if I come back and let's say we go Moldtec. Are you guys familiar with Moldtec?
I am not.
Okay.
No.
No.
Okay, so someone write down on the mural board, I want you all to go, well here, let me show you first and then I want you all to do this. So Moldtec is a company, and we talk about color, material, and finish. Okay, so for plastic components, Moldtec makes textured patterns, and they apply the texture patterns in the mold, which then transfer to the parts. So a perfectly smooth Gloss-A surface would be MT Moldtec 1001. There could be a texture that has, different coarsenesses. So you can see here, all these are Moldtec textures. You don't have to download them all. But if you look at a electronic component that has a slight texture to it, someone somewhere said this surface needs to be Moldtec MT7962. It's awesome because when I do my renderings, I can specify the material, the color, and the finish, and they're seeing it for real. Versus me just, like what I show you guys right now, I just fake in a texture. I add that noise thing versus going out and getting a real one. So if I come in here, and let's say this is going to have a very heavy texture. Let me just download a couple textures here. So I'm going to come in, very heavy, very coarse texture, and let's assume this is 1:1. Do I need to spend 10 hours getting that to be perfect? Or is this going to be good enough? You have to understand what manufacturing technique you're modeling for, what the end result is. Now, I can see here, I can see a transition edge, and I can see one there. It looks like a bit of a cutout to me. So I see that angle a little bit. I don't know if I like it or not. It's the reason we do prototypes. I'll show you guys later how I can 3D print this straight out of Keyshot with whatever texture I want. If I come in and I grab this 540, that is less of a texture. Well, now I really see that. So understanding your material. So this is a matte material with a texture. I still see that. Do I want to see that? Do I care? I personally do. Someone may not. I would never allow that. Not when the change is seconds. Now here's something that is always dangerous. When you're surface modeling, so I always like to understand, especially depending on how far, what is my manufacturing? Is this going to be injection molded? Before I start designing, what are we thinking? What are our parameters? This is going to be injection molded. Oh, okay. Or this is going to be rotational molded. Oh, okay. A little bit looser controls on that. This is going to be something that's going to be in the back of the truck bed. It's going to have a heavy texture. Because someone may come and say, Well, this is going to be the texture. Excellent. So you model it, you do your test, that looks good enough. What happens when someone comes and says, you know what, we've done some research, we're going to do that texture. Well, they didn't tell you that. Your model is already done. You've handed it off, you know, and they're doing that. Guess what's happening? They're now coming back to the designer who did the model and say, we switched textures and we got this big gap, we got this big edge in it. Oh, well, you didn't tell me. It looks fine with the other texture. That doesn't fly. It comes back to your model. For the sake of coming in and going, and this is where being aware of it, coming in, editing it. Well, let's go here. Come on. Tangent to face there. Tangent to face. Again, I like to come in. We'll evaluate it. Draft deviation analysis. Okay, I got something running in the background here. So you can see I got 0.01. Okay, that's going to be good enough for us. You know, let us update here. Well, it's gone back there. The only thing that I'm seeing here is that maybe it's not as smooth as I would like it, but there's no angle. So now I'm comfortable whether they use that texture, whether they use that texture, whether they use that texture. I'm not necessarily happy with the form because it's kind of a little bit abrupt. But if that's what they need, I'm happy with that texture. That texture, I'm not seeing those angles. Now let's go to, do I have? One second, I want to see. Never mind, I'm getting sidetracked. So understanding your material and keeping that in mind, especially when you're doing your renderings, is really important. At the start of a project, you know, you guys are given assignments. How many times at the start of a project are you guys defining, you know, what it's going to be, how it's going to be made? Is it going to be plastic? Is it going to be metal? You know, or are you guys still doing projects where it's very open? It's like, well, it's going to be whatever I want it to be. Let me come up with the concept first, and then I'll worry about the materials later.
We do usually do that last, yeah.
Okay. Try to switch it around. Because when it comes time to do something, you know, I'm going to design, like, I shouldn't say that. Okay, ignore that direction. That's going to take you in a different direction than the teachers will do. It's all part and parcel, though. You really need to know that. You know, for example, if it isn't already defined, the bike lever that I was doing, you know, here's a taste of reality too. So the bike lever that I was just in the process of designing, you know, I know it's got to be cast. That's how they're making it. That's their volumes. It's made out of metal. It has to be a cast product, you know. And then it really, really sucked because they're like, yeah, what are you guys thinking about the finishes? And I was like, well, here's what you should do. This part should be polished and then have matte black on here with a light vapor texture. And they're like, yeah, we tried that, but we can't do it. Why do you think they can't get a nice matte black finish on a cast black part?
It wasn't designed for it.
No. Because their vendor.
The mold finish isn't smooth enough.
No. Their vendors don't care. Their vendors will not take the time to do it nicely and to do it properly, because they are such a small client that the vendors make them feel as if it's a privilege for them to actually be making the part for them. So when the vendors do it, they can do it, but they don't take quality control into it. They just kind of half-ass it, which means without that quality control, when they do it, it looks like crap. It's inconsistent. That's really sucks. So then as a designer, well, that sucks because it's a $400 handbrake. How can we come up with a finish that looks good, you know, that their vendors are going to be able to successfully do? Talk about heart-wrenching industrial design. When it's like, this is what's going to make it look beautiful. Like, I mean, all I'm asking for, match my watch. You know, matte black here, gloss there. That's easy to do. You see it on thousands of products. But my client doesn't carry enough weight to get the vendor to do it right. And they don't have any other vendor options. But as designers, we still want to make sure that we have to take that into mind. And then this also goes into, you'll hear a lot of designers, you'll hear a lot of people still teach and preach, well, manufacturing is going to ruin your designs. Engineers are going to ruin your designs. You know, marketing is going to ruin your designs. Well, I want to have that. Someone may just come to you and say, well, you can't have that. We're not doing that. You know, you need to do this. Someone's going to blame that person. Well, no, it's not that person. Here's why that's happening. So what is our job? My job isn't to say, well, find a new vendor. You know, what I told him was, our job is to make you big enough company that, you know, you can go anywhere and they want your business. But to come up with something that's going to work, you know, that's going to do that. If it's changing the design to make it easier or, you know, whatever. That's kind of, that's really a side rant on materials and finish. But that's some of the stuff that you guys might experience. Either you'll be directly involved with it, or it may be indirectly where someone comes back and says, you know, where were we here? We know you want it. Man, where are all my... We know you want it this. Or we know you want it this, but you're getting this. When that happens, what's the very first thing you should do?
Fix it.
No. So if you tell me that this is what you want it to look like, you want this material, and I come back and I say, yeah, that's beautiful. Guess what? You're getting that material. What do?
Are you saying as the designer or as like
Yep.
company?
As the designer. You as the designer specified this, which is very nice looking. And
Are you
as
saying the manufacturer says that they can do it?
what's that?
I mean, you're saying as the manufacturer is the one who says, well, you're going to get this instead?
Someone is telling you. Anyone is telling
Well,
you.
I guess if it was the manufacturer, as a designer, you might not be able to just say, that's fine, obviously.
Yeah. Well, so the first thing is always ask why. Why? Why? Why though? And here's psychology of